The next speaker is Dongmin Park from Seoul National University, and he's going to talk to us about a study on added resistance for green ship technology.
I'm Dongmin Park from Seoul National University. I am a PhD student. I will brief you my research progress on study on added resistance for green ship technology. What is added resistance? There's two pictures show the ship is sailing in calm water and waves. In calm water, we can get steady pulse like this blue line, and then in waves, we can get the oscillation pulse like the red line. Added resistance is increased resistance in seaway due to the wind and waves. Recently, IMO has introduced the EEDI regulation to reduce the greenhouse gas emission. We can get EEDI using this formulation here. Weather factor is an important parameter. Weather factor is a ratio of ship speed in sea condition to reference speed in calm water. In the computation of weather factor, added resistance is an important parameter. In this slide, I will show the experimental research on added resistance in time order. In 2012, I set up experiment for added resistance and experiment conducted for 3 different bow shapes, and we can get the reduced of added resistance like this figure. In 2013, uncertainty analysis of experiment was conducted, and we can get this uncertainty analysis. And from the uncertainty analysis, we can get the source of uncertainty, and the source of contribution of source is evaluated. And 2014, appendage is designed and attached like these figures, and we can get reduced of added resistance. And 2015, to consider the operation condition, added resistance experiment was conducted for various draft conditions. Float condition, ballast condition, and 2 conditions between float and ballast condition. And we can get result like this. And now let's move on to the computational result. In 2012, I used 3 methods and moment conservation method to compute added resistance. And 2014, added resistance was computed using Rankine panel method, and we compared the numerical result and experimental result. And 2015, far field method is applied, and we compared with near field method and far field method, and we get almost the same result. And 2016, the flexibility of body is considered like these figures, and we can get the decrease of added resistance like these figures. And this is the result of my publication result. Thank you very much.
Thank you very much. And questions, please.
Hi, I have a question about the flexibility of the hull structure. How much does it affect the actual resistance in terms of increase or decrease? And should we do something about it?
That depends on the flexibility of structure. In our case, I changed the flexibility of shape. In the near the resonance region, it is increased. In wavelength is similar to ship length. That region, hogging and sagging is happen, and this region, the added resistance decrease.
Thank you. I really enjoyed that. It seemed as though your starting point was, and forgive me if I'm wrong, but it seems as though your starting point is adding something to the design rather than starting the design from scratch. Is that latter approach something that you considered as well? When you set up your experiment, yes, you were adding something to the shape of the boat.
Shape of boat?
You were putting something on the hull, an appendage.
Yes.
Rather than doing that, did you think that your starting point might be just changing the shape entirely?
Oh, the appendage is very small portion, so there's not big change in the shape, in total shape of body.
Thank you very much. Great. Moving on, we have Eric Shakel from the University of Twente. His talk is regarding a framework for developing scalable maintenance program for unmanned aircraft systems.
Good afternoon. I'm Erik Schakel, a master student in mechanical engineering at the University of Twente, and currently graduating at the chair of maintenance engineering on a framework to develop scalable maintenance program for unmanned aircraft systems, or in short, UAS. Currently, there's a rapid increase in the use of UAS, both commercially as by hobbyists, which raise new public safety challenges. One of these challenges is the need for a proper maintenance program to avoid potentially catastrophic consequences which arise if the UAS falls out of the sky due to system failure. The absence of strict regulations regarding maintenance and the absence of a specialized maintenance framework to cope with the unique nature of UAS design only attribute to this challenge. So why do we need a specialized maintenance framework? Well, it provides a structured and consistent method of developing maintenance program, but more importantly, it considers technical characteristics of UAS design. So how is it realized? The created framework is based on a reliability-centered maintenance method, one of the most used methods for developing maintenance program for systems where reliability plays a vital role. So there are multiple important characteristics of the created framework. First, it develops a scalable maintenance program. Scalable means that it uses clear rules to determine maintenance policies for the most important components first to ensure safe flight of the UAS. Furthermore, it provides rules on how to expand this maintenance program when time and resources allow for it. Second, it acknowledges the technical characteristics of UAS design. An example of this is the high rate with which components are updated or replaced and the implications of this on the development of the maintenance program. Third, it is presented in the form of a flowchart to realize a user-friendly approach and lead the analyst through the process to avoid subjective decision-making issues. This is important to ensure an easy accessible solution for UAS developers. In order to evaluate the framework, a pilot study was performed at Aerotronics, a commercial UAS developer, which yielded positive feedback on both the results as the process of the framework. So in short, the created framework provides an easy accessible solution and let UAS developers focus time and resources on the most critical components to ensure safe flight. This reduces their accident rate and thereby improves public safety to avoid potentially catastrophic consequences which arise if the UAS falls out of the sky. Thank you for your time.
And questions?
Hi, I wondered if you were aware of others who have built any actual asset models to represent UAS to do further reliability analysis on? Rather than a framework, have you actually broken the components of different systems down, modeled them for reliability modeling purposes?
Yeah, there's quite some research available on the reliability of UAS and components. But the problem, especially in Holland and Aerotronics, who contacted university, is that the absence of regulations and an easy accessible solution make it very hard for UAS developers to focus time and resources on their maintenance program. It's a very innovative market, so a lot of their budget and time goes to R&D, which is the most important part, and maintenance is rather, well, not considered as well as it should be. So the first step in this process was to create a framework to realize all important aspects of the development of a maintenance program, and the next aspect would indeed be to add reliability engineering to it.
So is this feeding into any of the regulatory authorities? Because there is work being planned now to have regulation for UAS.
Yeah, that's funny that you ask. A person at Aerotronics is in contact with a foundation who recommends the law, but also is in contact with insurance companies. And he was very positive about the framework. And he's proposing it as well to the foundation as to insurance policies to see if it can become a requirement. So it's still ongoing. The results are just finished. So hopefully in the future.
Okay, thank you very much. Great, thanks. Next, we have Yolandi Sherman from Monash, South Africa, talking about floating treatment wetland island, a green technology developed for ecologically treating polluted aquatic ecosystems.
Thank you very much for this opportunity. First of all, I would like to see a show of hands. Who is familiar with nature-based solutions engineering? That's great stuff. Okay, so part of my research was focused on water quality and also optimizing water quantity. These are examples of floating islands that I've developed as part of the research. So what is a floating treatment wetland, some of you might ask? It's basically a natural-based solution to some of the sustainability challenges that we have in water, and it consists out of intelligent plants that can take out contaminants from the water, a floating buoyant base, and also extensive root systems that are known to take out contaminants from the water. Now, together with the research that we've done on the floating treatment wetlands that can be used for fish spawning, for erosion control, it can be used very greatly as a wet and a dry application in mine rehabilitation. It can also be used for wetland rehabilitation as well. We've developed a decision-making framework as well, and also a model to see exactly what impacts and what affects the diffusion of floating treatment wetlands as an eco-technology. Because the difficulty that a lot of inventors have is that you develop a great invention, people don't want to adopt it. So together with that, we've developed a model that addresses the diffusion of eco-technology that can be used by policymakers, consultants, program managers that will be implementing eco-technology. And then we went further. We actually put the floating treatment wetlands on steroids, and we've developed a wetland in a box. A wetland in a box is also a natural-based solution to water purification that includes a rainwater harvesting and a rainwater and greywater or contaminated water treatment unit that can eliminate 99% disease-causing microorganisms. It can adjust the pH, and it can improve the water quality by at least 80%. Now, important is that this can also be used in disaster areas. It can be used by everyone sitting here. You can have a wet box outside your house, where you can optimize your water that you use every day. It can be used in Africa, in people that don't have access to clean water, and it can also provide downstream opportunities. I want to leave you with a final thought. Perhaps many of the sustainability challenges that we have today can be addressed by natural solutions, nature-based solutions, that can also immensely contribute to bringing safety to life sustainably.
Great. Thank you very much. Tim.
Hello, I really enjoyed that. But as you were talking about your the development of this technology on steroids, and you mentioned the wet box, what's it made out of? The box itself?
It's got a recycled plastic that's very robust for outdoor usage, and it's got a biological filter inside with microorganisms as well. And the best of all is that the plant's roots are exposed to the water, which in many times are more efficient than a constructed wetland in taking up contaminants.
Okay, that's what I thought. So my question then is, do you think there's any difficulty in implementing this solution using plastics, given that you're trying to create a natural solution to what is a very real problem?
Well, not at all, because the available material that we had for the testing and developing the minimum viable product showed the best in terms of looking. It needs to be UV stable as well. And obviously, when it goes into redundancy, you can recycle it fully. And what I didn't say is that it's also a carbon sequestrating device. So it can fit in greatly with any kind of climate adaptation and mitigation strategies in your region and in your province and in your country.
I've just got one more question then, which is, so you showed how it can be scaled down. How much could it be scaled up?
You can scale it up to treating 50,000 cubes of water.
Okay.
Yes.
Okay, thanks. Thank you very much.
Okay.
So our penultimate talk is from Stavros Sidiropoulos from Imperial College, and he's going to talk to us about optimization of thermal airspace operations in Metroplex systems.
Hi, thanks. Good afternoon. Typically, major cities such as London, New York, and Tokyo are served by several airports, effectively creating a multi-airport system or Metroplex. Today, with more than half the world's population residing in urban areas, Metroplex systems are deemed to play a major role in the future of aviation, directly affecting the quality of life. Here we can see the 59 Metroplex systems today. Excuse me. So there are, as you can see, most of major cities around the world are Metroplex systems. Now let's focus on the most complex one, which is in New York. The New York Metroplex accounts for 20% of all air traffic delays in the US. Here we can see the main 4 New York airports, JFK, LaGuardia, Teterboro, and Newark. The area around the airports is known as the terminal airspace, and this is where all the arrivals and departures take place. Today, arriving and departing flights are supposed to follow a set of standard arrival and departure routes. The close proximity of the airports in a Metroplex system leads to high airspace complexity when it comes to the design of these routes. So air traffic controllers have to manage traffic in an ad hoc manner, which leads to several system inefficiencies. For example, I'm sure that many of you have experienced flying around in circles before landing. This is known as a holding stack, and it is such an inefficiency. To improve operations in Metroplex, I have developed a new design concept, which identifies when and where flights are coming from, and breaks down the operational horizon into distinct periods to reflect the important traffic patterns. The idea is to design airspace dynamically for each of these periods. Subsequently, I have developed a route prioritization model to enable the decision maker to take informed decisions and incorporate these decisions into the design of 3D arrival and departure routes. These routes are conflict-free to ensure safety, they account for aircraft maneuverability, and they are optimal in terms of the total distance traveled. Moreover, they can avoid areas that are affected by convective weather. To test the effectiveness of this concept, I have conducted simulation and compared the current operations, which you can see here, to operations under the new optimal design, which you can see over there. You can see that the new design results in a much simpler distribution of flight tracks compared to what happens today. Here we can see a simulation of traffic under the new design for when all airports in New York operate at their maximum capacity. With today's system, this would not be possible without major delays. Having tested several simulation scenarios, I have managed to obtain significant reductions in distance traveled, flight duration, fuel burn, delays. This would be translated into $2 billion saving a year. And finally, control workload, which is of significant importance in relation to safety. So if we want to maintain current safety levels and increase future safety levels, this is very important. Finally, I have validated my framework, my simulation, and my results with the Port Authority of New York and New Jersey. Thank you very much.
I like the thought of 2 billion savings. That sounds pretty impressive. Have you talked at all with the authorities as to what would be some of the barriers to implementation of your new approach?
Yes, I have extensively, actually. So I spent 3 months in New York last year working with controllers from the Port Authority and the Federal Aviation Administration as well, the FAA. So basically, we have run through the model as the concept initially, the design, the application design, and also the simulations. So basically, the simulation also includes a model for the controller workload. So it simulates what the controller would do in such situations. And having the simulation and also the controllers themselves, they validated that this could be implemented.
So what's the next step?
The next step is I'm now trying to make this into a more complete software. And we're still working with the Port Authority to see how we can take this forward.
And my last question would be, have you considered the degree to which the crux of the method you're using here would be advantageous to applications in other intense logistic situations, whether it's inbound units into a construction site offshore or into a complex port operation?
You mean to add the transferability to another industry?
Yeah.
No, I haven't done this so far.
Intuitively, do you think it would be advantageous to apply it?
It could be, yeah, because it's still about routing. Mm-hmm. So routing can be applied to shipping, to road traffic, to anything, basically.
I wanted to understand whether you took into account things like flight paths.
I did. I actually designed the flight paths. So the third part of my model, the third part where I talk about design of 3D arrival and departure routes, I actually designed them. It's an optimal design. So for this I count, as I said here, they are conflict-free. So you have different paths that there's no conflict between them, okay? They account for aircraft maneuverability so that aircraft can actually fly them. And they are also optimal in terms of the total distance they travel within the terminal airspace. So it minimizes the total distance. So I take this design, I simulate it, and then I get these results. That's how I got it.
Thank you very much.
Okay, thanks.
Great. And last but certainly not least, have Richard Wilbraham from Lancaster, who's going to talk about the safety of new actinide separation processes for plant steel corrosion.
Thanks for the introduction, Mike. I've got the unenviable task of being the last person today, but I'd like to talk about, yes, the safety of new actinide separation processes, and particularly steel corrosion. So with the Hinkley Point C being green-lighted by the UK government, the UK is shortly to invest in a £500 million national R&D programme for future nuclear, in particular looking at reprocessing of new nuclear fuels as well. Now, Europe and the UK are seeking to design a new process that groups minor actinides together and produces an impure plutonium product, so something that's proliferation resistant. And this is shown here on the right. The flow sheet is going to be called the Euroganics flow sheet. As such, in the last 3 years, we've done this work over the last 3 years, a large UK-European collaborative project was set up to investigate safety issues that may arise in these new flow sheets, the Success Consortia. Now, as part of that, the Institute for Radiation Protection in France carried out a number of studies of previous reprocessing accidents and identified 2 ways in which corrosion in particular could lead to structural integrity and resilience issues. First, the corrosion of check valves, shown here on the right, leading to maloperation. By maloperation, what we mean is excess nitric acid or oxidizing actinide ions entering a stream they shouldn't be in. Secondly, you could have significant deformation of the geometry of a pipe, mixer, contactor, and a consequent criticality event, of course, can be very negative. Now, with this new Ganics process, in order to hold back and extract these minor actinides, they use novel ligands, BTP and AHA, that's bis triazyl pyridine and acetohydroxamic acid. And they're both under test at the moment. They work by extracting actinides and lanthanide ions at the 3+ oxidation state, but the question we came to is, do they also extract the constituents of processed steels, which are such as iron 3 and chromium 3? So here's a summary of the results from the last few years. And these have all been carried out using electrochemical corrosion methods. And we tested 2 conditions, normal process conditions as well as maloperation conditions, where it's expected to be extremely oxidizing, high amounts of nitric acid and actinide oxidizing ions. And what we find is under normal process conditions, nitric acid on its own has little effect, but we actually get a reduction in the corrosion dissolution rate, shown here on the left, by the formation of a monolayer of BTP and AHA at the surface, restricting corrosion. However, under maloperation conditions, where the steel is already actively corroding, what we find is BTP and AHA actively work to extract iron from the steel and therefore drive corrosion, accelerate it, which of course is a major safety concern. So what's the outcomes from this? Well, it's been recognised twice by the Success Oversight Committee as of international importance. Secondly, corrosion as a result of inventory permutations has been reported as being a safety critical aspect in the final Success Review report. And so as part of this, we've actually been invited to be a key part of the Success follow-on GENIORS, which is going to look at further inventory permutations and the XAM process. And this consortium will be the reprocessing consortium in Europe. Interestingly, the XAM process actually uses higher nitric acid as well as TEGA, which could result in even worse corrosion at this maloperation end. Thank you.
And questions, please.
Just a question. Is corrosion different? Are corrosion processes different in a radiation background?
Yeah, there is something we haven't considered is the actual effect of radiolysis. For example, if you have the radiolysis of the nitric acid, you can get different, more oxidizing products off from that, as well as radicals like hydroxyl radicals, etc., that can also tear into steels. So this is almost a baseline without that radiation element. We haven't gone to the fact of using actual active ions yet. So there is also a concern there as to what that would do in the stream as well.
So presumably one of the problems is once these things are set up, you don't really want to be going in and changing things very often. I mean, is it possible to have something that you can sort of put through that cleanses the system?
Yeah, I mean, one of the things we're exploring is how these things could be broken down. I mean, there is possibly some elements of radiolysis that breaks these ligands down anyway. But yeah, there is ways of flushing through with higher nitric acid concentrations, different solvents. One of the questions could be also a lot of irritation. They could be maybe jogged off the surface, possibly through ultrasonics, for example.
Okay. Thank you very much.